What's coming in the future? Few things. Our next focus is going to be on providing a recipe to launch Cachero Ensemble in Linux in the Amazon EC2 environment. And we're going to pick SUSE, simply because RightScale has done a lot of work with SUSE to create these pre-built recipes for these machines in the Amazon cloud. Once we've launched that, we will start looking at some of the different cloud service providers. So as I mentioned, from a public standpoint, there's Rackspace, very popular in Europe. And there's a few others. And then private is CloudStack, et cetera, et cetera. So we're going to start looking at some of those. And then we'll start looking at some other pricing models as well. Because right now, as I said, the way that it works is you purchase a license from us, and you put it on there, and you just run. So there's no special licensing or no special pricing for running our stuff in the cloud. So let's see if this demo instance is running. I know everybody's holding their breath. So let's see what happens here. Let's refresh this guy. Okay, so it's still booting. It's not up yet. So that's fine. That's okay. We still have 2 more pieces of the presentation, so we can always come back to this to see if it's finished booting. But it's been 20 minutes. That's okay. All right. So in closing, for the cloud piece, we're very, very happy to help you evaluate whether if your options in the cloud, and if you decide that you want to deploy in the cloud, please let us know what your plans are, so we can participate and we can help you as needed, but we can also learn from your experience, and other customers can learn from that as well. So do you have any questions on the cloud piece before we move on to the next topic? Or you can wait till we get to the end. It's up to you. Okay. All right. Moving gears. Database mirroring. I should change my tie, so I'm a new presenter, new session now. Okay, so I like to start this session out with just some numbers, which are, I think, they make you think and make your head hurt, make my head hurt sometimes. Gartner estimates that, and this is an old estimate, this was in 2002, Gartner estimated that, or 2003, that an average IT shop, if their servers went down or were not available, it costs an average IT shop around $42,000 per hour in lost revenue. Okay? If you go up the scale all the way to PayPal, PayPal estimates that they lose around $7.2 million in transactions for every hour that their systems are down. Okay? So I don't know where you fall, but it's got to be somewhere in there. and even $40,000 an hour is $40,000 is a lot of money, right? Even $1,000 is a lot of money. And then you have all of the other stuff associated with that, where you have the public perception of your application. You want to make sure that people don't think that your services and your applications are unreliable. You want to make sure that they know that they're highly reliable and available. So this is one thing to keep in mind when you're looking at your infrastructure and you're looking at your deployment strategy. High availability disaster recovery should be right at the top of your planning process. Okay, so there are many different ways of achieving high availability. You can start from the left side for redundant systems, which means that instead of having one server, you have 2 servers. Instead of having 1 network card, you have 2 network cards. Redundant systems, right? All the way to a sophisticated continuous availability end of the spectrum. And this is very, very hard to achieve, the continuous availability. So most people go in the warm standby or the automatic failover category. And what you see here is that as you go from the left side to the right side, you go up in cost. You'll go up in complexity because it's more complex to set up and manage and administer. But you also go up in availability. So your systems are more available. So it's a balance. It's a trade-off. So you have to decide based on where, what your SLAs are, what you have agreed to with your customers and internally within your organization, and weigh that against the cost. I've had many cases where I've gone into conversations with CIOs and CTOs, and they say, I want 6 nines of availability, right? 99.999%, 9999%, 6 nines. And that means, you know, a few seconds of downtime every month, okay? And so I draw a table for them, and I write that down, and I say, okay, well, what does that mean for you? How are you going to do an upgrade? How are you going to do maintenance? How are you going to, you know, do any of that stuff? Like, oh, how about 4 nines? So immediately the thing changes. It's just about understanding what is acceptable to you and what cost you want to pay. So what we looked at was this graph from Gartner is a really nice graph. What this shows is this is availability, level of availability on the x-axis. It starts from 95%, and it stops at 99.9%. So this is 3 nines, okay? What we found by looking at this was, if you want to go from 95% to, let's say, 99.5%, the additional cost is minimal. You're paying more, right? You're paying more if you have more availability. But suddenly you see this knee in the curve, where the curve just completely changes. So going from 99.5% to 99% availability, the amount of cost that's incurred is tremendous. Okay, so this was a study that Gartner did. So we looked at this and we said, well, there's got to be an easier way. There's got to be a way to provide very high levels of availability at lower cost. And that is what we came up with, is mirroring. And we did a demonstration of it last year. I don't have a demo for you this year, but I'm more than happy to talk to you about it later. At a high level, from an architectural standpoint, a mirror consists of 2 systems. 2 failover members. One of them becomes what's called the primary. The other one becomes the backup. And these roles can change. These roles are interchangeable. It's not that one system always is the primary and the other one's the backup. Data always goes from the primary to the backup. So in this case, from the left side to the right side. And acknowledgments for this data, acknowledgement receipts, go back in the reverse direction. We've had this journaling module in Cache forever. And so we just used the same thing to synchronize changes. We didn't create anything new. We already have a way to capture all of the stuff that's changing on the system today. So we just tied into that, and therefore the synchronization process is very, very robust. It's not something new that we've created. We created this new concept of the mirror virtual IP, where when you configure a mirror, you can optionally specify an IP address, which will automatically, we manage the assignment, automatically get assigned to the running primary system. So right now, the blue one is primary, so it would have that virtual IP assigned. If you did a failover and the orange one became primary, it would get the virtual IP. So why would you want to do that? Well, all of your external applications, if you're coming in from web clients or you're coming in from a telnet or anything, they only have to know one IP address. They don't have to know 2 IP addresses, right? So they just access your system with one IP address. ECP, Enterprise Cache Protocol, which is our tiered architecture, allows a much higher level of availability with mirroring. We've built into the ECP protocol knowledge of mirroring. So when an app server connects to the data server, it can detect, oh, yes, you're a mirror, and oh, by the way, what's your partner's information? Okay, that's your partner's information. Now, if he detects that there's a problem and there's a failover occurring, he just waits till the partner is available and then reconnects. This has profound implications for availability. Again, thinking about the levels of availability you want, consider this. Let's say you open a transaction, right? And you set some data, and you have a web application, and you're entering in some information, and you have this transaction that's open. And you spend a little bit of time typing, and you go to hit the save, and the server crashes, right? When the server restarts, the transaction will get rolled back. You'll lose whatever you entered. It'll be a consistent database, but you've lost what you've entered. Now, from an ECP standpoint, if you're entering this data on an ECP application server and the mirror data server fails, the other guy takes over, your open transaction remains open. All of the work is still there. It gets honored. Your locks get honored. Everything else gets honored. So all you notice is just a slight pause in the time that it took to fail over. Okay? You don't have to reconnect. You don't notice that, oh my God, I lost all my data that I was typing in for the last 20 minutes. Right? It's all there. It's just there. So that's a very high level of availability. Good things come in threes. There are three main benefits of mirroring. Lower cost, faster failover, easier maintenance. And we'll look briefly at each one of these. We did a study. We took 3 actual real live track care configurations from around the world. We classified them in small, medium, and large, depending on the number of episodes, number of admissions, et cetera, that they had. And the blue bars are their original configuration with OS-based failover clustering, so Windows failover clusters or IBM's Power HA or HACMP as it was known, et cetera. And then the red bars are what their configuration would look like if they used mirroring. And in this graph, shorter bars are better. Shorter bars means less money. So from this perspective, you see that there's a small gain in the small configuration, but the medium and large configuration have roughly around 50% reduction in cost when they use mirroring. Okay? Now, why is that? Well, so we broke it down by category. And there's 4 main categories in a configuration. There's hardware, support, operating system licensing, and storage. And you see that the biggest wins are in the operating system licensing and storage components. The operating system vendors are very smart. You have to buy a special operating system license from them if you want to use their software that allows failover, which you have to pay more for anyways. So you have to buy a premium version of the operating system, and then you have to pay extra for the privilege of using the software to do the failover. Okay? With mirroring, you don't need any of that. You can get the base version of the operating system and you're done. So you save a lot of money there. And the storage thing is very interesting. Failover clusters require shared storage. Mirroring doesn't require shared storage. So if your application can sustain itself on well-configured internal disk or even network-attached storage, then you can save quite a bit of money on not having to purchase a SAN of some sort and instead use internal disk. And that's where you see a big saving in the storage department as well. Okay. We said that one of the features was faster failover, or one of the benefits, rather. The process is very simple. It's a warm failover, warm failback, which means that if I have a system that's running as a primary and I have a backup failover member and something bad happens to the primary, the backup will take over. But just imagine this. The buffers on the backup are already warm. They already have all of the data that was going on in the system, all the sets and kills, all the transactions, everything else is all there. So when users connect to that system or continue with that system, they don't have to suffer. They don't have to slow down to do more disk reads to pull that data in. It's already there. It's warm. It's ready to go. Right? And you can do warm failback. And it takes seconds instead of minutes. So traditional operating system failover clusters take minutes.